It's a new day, it's the start of a new course, let's talk about some materials. Making materials is going to be a quite important thing for making your games, and in my Unreal Basics course I said at some point in the future I'm going to do a materials basics course, and this is the day. We're getting started today. I've got a lot to talk about, so let's right away get into the start here. First thing we do is we just go and make a new material right away. And I'll just call this for now a tutorial material, just to keep things simple. This introductory video is mostly going to be going over the most important basic things that we're going to be using and referencing a lot, and I need everybody to be on the same page about this. So first and foremost, we've got our material graph here. Here we're going to put in all of the nodes, and we're going to do like a lot of math and a lot of fancy stuff to make the material effects that we want. So if we, for instance, add in a vector 3 constant, which you can also do by just holding down the 3 key on your keyboard and clicking. Same thing with a vector with 2 values and a scalar value, which is just 1 value. You can even do it for a vector with 4 values. So that's how you make these constant values very easily. You're gonna see me like just spawn in a lot of these throughout the entirety of the course, so that is the first most important things. Now, once we have a value, this can be a texture or a constant or whatever you want, we can plug these inputs into any of these outputs. And I'm not going to talk about all of them because frankly a lot of them aren't going to be relevant until we actually talk about their specific relevance. But the most important ones are going to be the ones we talk about here. So first and foremost is the base color. And you can see as we update this, it's just the color of your material. Let's just keep that at pink for now because it's a nice color, or maybe let's go with a bluish color, bluish purple. That's a little bit more pleasant to look at. Then next up we have metallic. Metallic is usually a grayscale value, which is just to say it's from 0 to 1. Base color is something that you usually put an RGB value in, so something with 3 values. Metallic only uses a 0 to 1 scale. So if we put the metallic into here, you'll see nothing actually changes. Until I set this to 1, at which point it just becomes a little bit more metallic. There's a lot of technical explanation, which I'm going to be frank with you, I don't have the skill to explain to you what this does under the hood. But this is just a part of the PBR, which stands for physically based rendering pipeline, which a lot of modern engines use. And there's just a value for metallicness. That's just kind of everything you need to know. Usually this value is just straight up 0 or 1. You can put any value in between, like this being semi-metallic. That is a possibility. I don't end up using any values other than 0 or 1 all that often. So we're just going to stick with 0 for now. Then we've got specularity and roughness. I'm going to go for roughness first because roughness is the amount of reflectiveness that your material has, which again is just a scalar value, just a scale from 0 to 1. So the default value for that will be, I think, 0.5. If we plug it into this, you can see the roughness at 0 makes this very, very reflective and very shiny. But if I put the roughness up to 1, it is entirely non-reflective and almost looks like chalky, very diffused. The reason it's called roughness here is because this is how a rough surface deals with light. If you have a very smooth surface, like a mirror, that reflects. If you have a very rough surface in real life and you shine a light on it, it scatters the light all over the place and as such doesn't give good reflections. Now, why did I skip specularity? Because for the most part, you're just going to not touch that all that much. But specularity has to do with the highlights on reflections. Now we have a very like hotspot highlight here. If I just open this material editor as like a little bit of an overlay here, and we change the specularity to 0, you will see that it is a lot smoother in its fall, which is very closely related to reflectivity, but it's technically something slightly different. Again, if you're just going for reflectivity, you're going to play with your roughness. I could go into a very long, drawn-out explanation. Just remember that it is the intensity of the highlight spots in your reflections. and that for the most part, you're just gonna not touch it. And the same one for, I can never pronounce this one, but the one under Roughness, that's just to do with the specularity as well. Again, we're not gonna really touch that. The more important thing though is the emissive color. Now we get into the interesting shit, right? So if we disconnect the base color here and instead hook this up into the emissive color, initially you might think that this doesn't really do that much. It's a slightly lighter color, but that's about it, right? Well, this is where we get into some interesting shit. We'll talk a little bit more about like math and multiplication and stuff like that in the next video. But if we multiply any color value, an emissive color can go beyond a value of 1. Everything in a material is always on a scale from 0 to 1. Emissive colors can output things beyond a value of 1. So if we have our color here and we multiply that by like 5, you can see that it starts to have like this little bit of a glow around it. If we like make this 50, you can see it even more. The material itself becomes pure white because the color that it's trying to display on the surface is way beyond a value of 111, which is just pure white. But the color around it that it is now emitting is the color that we put in. And if you're using lumen, global illumination, this actually also does emit actual light into the world. So right here you can see we are not using lumen by the looks of it, because it's not emitting light into the world. If I now set my graphic settings a little bit higher to something like Epic, for instance, you will see that, hey, now we're suddenly emitting light from this thing. So that's just a graphic setting thing as well. So that's quite nice that you can emit light from materials. It's not particularly efficient for lighting, but it can be really, really nice. Now, if we use this multiplied value and instead of putting it into the emissive color, we put it into the base color, it will just be white. And that's about everything there is to it. So if we go here, it's just white. You'll also note that when you use emissive color, your metallicness and your roughness really don't matter because emissive color kind of overrides pretty much everything that's happening on the material itself because it's not interacting with light hitting it anymore. It itself is now emitting light. All of this stuff is just telling the material how to deal with light hitting it. And if the material itself is the thing emitting light, it's not actually dealing with how light interacts with it as well. So that's an important distinction to make. Let's go back to the base color here for the moment because I want to show you some other things as well. Next up we have the normals. If you don't know what a normal map is yet, it's kind of annoying to explain, but I will try my best. So a normal is the perpendicular angle of a face. So if we have a mesh like this right here, this face here is going in a up and down direction. It's actually exactly aligned to just the world Z direction, just the up direction, right? The normal of these faces will be pointing out perpendicular to that. So they will be pointing out into this direction in the X direction exactly. Now, that's the normal on a per face basis. That is the normal of your mesh itself. What a normal map can do in a material is, instead of calculating that on a per face basis, it can calculate it on a per pixel basis, meaning that you can pack in a lot more detail into your materials and your textures without actually having that detail present in your 3D mesh, which is a lot more intensive to render. Now, with things like nanite becoming more and more prevalent in workflows for games these days, you might think that you don't need that anymore, but still, it's really good to do, especially since you can generate this procedurally fairly easily in some cases. And we still have things like skeletal meshes that don't support nanite. If you don't want nanite on a mesh for other reasons, which we might get to in this course, you still have all the options for detail in your normal maps. That being said, if you get real close to the models that have these materials with the normal maps on them, you can see that there's no actual like depth there. It gets most of the way there with faking it. So what I'll do is I'll put in a texture sample real quick, and I think we just get some normal maps given to us. So normal maps will be looking a little bit like this. A very similar color actually to what our base color is that we chose. So I'll choose this default normal map for like, I think it's a tiling thing. And if we put that into the normal input here, we can see that we get some interaction with the light. It's casting shadows inside of itself, even though there's no geometry to support that. And I'm just going to change the color of this because I don't want you to confuse the normal map and the actual color that we have. So if I real quick go into modeling mode here and I add a extra little block here that I can put a material on, something like this, and I put our material on that. And just to make things easier to see, I'm going to make the roughness set back to 1. And now you can see there's a little bit of like texture detail in here, even though there's no actual mesh to support any of that. And the nice thing is, this is not just like an image that is projected onto this mesh. This will actually actively interact with light as well. So it might be kind of hard to see, but if I move across this with the light like this, you can see that there's a little bit of like updating of shadows. Specifically, look down here, not so much on the line up here, but the lines down there. As the light moves around it, you can see that it's casting shadows in slightly different ways onto its own texture. So that is what a normal map can do for you. Now, then we have tangents, which ties back into the whole specular thing mostly, so we're not going to be talking about that, because again, it's a nightmare to really work with, and you're not going to do it that much. World position offset, though, is an interesting one, because this can be a, like just a value going from 0 to 1, as always, or more, actually. And this will offset vertices, so points in your 3D mesh, in 3D space based on a texture. So if I use a texture sample here again, and I will put in a noise texture, which is just something that the starter content offers you, and putting that into the world position offsets. If your mesh is high detail enough, this will now start distorting the mesh vertices all over the place. So I'll subdivide this mesh a good few times until we have like a very smooth mesh, and I'll just do that in a linear way. Checking this on wireframe now, we've got a whole bunch of detail packed into this. And for now I'm just going to add this vertex world space normal, and we're going to multiply that with the texture sample, and we will multiply that with a just a value to make it a little bit more extreme, just to show you. Don't worry if you're not keeping up with this, but now you can see that there's some displacement of these vertices based on the texture input here. And it will do that for this mesh as well. This is, however, limited to the mesh resolution. So if you have a very low resolution mesh, this is not going to work too well. And if you are wondering what this is doing, if you don't get this, don't worry about it. We'll get to it at some point in the future. This is taking the vertex normal, so every single point in your mesh has a normal. Again, the direction just pointing outward from it. And then it's multiplying that normal by a grayscale value here. So that is the amount that specific vertex is going to get displaced. And then I just multiply that with a general number that makes the effect just greater all over. And the last important one that we have to cover is the ambient occlusion, because when you're dealing with lighting situations, specifically for static meshes a lot of the time, there's this effect where if you have a little corner in a room, for instance, the places where lines come together tend to be a little bit darker than everything around it, just because of the way light bounces around. And generally speaking, that is kind of a pain to like simulate in a lighting engine. So the way they get around that is to have a ambient occlusion map. So this also is just a grayscale value. So that's 0 to 1, or again, a gray texture like this. But in this case, you really do need it to be a texture. You can't just do one number over the entire material because that kind of defeats the purpose. And in this, it's kind of difficult to show you what it does. So instead, I'm going to just put an image on screen right now that shows what ambient occlusion does. Now, then we have things like refraction, pixel depth offset, shading model, surface thickness, all that stuff we're not going to talk about. Refraction could be interesting. That's just literally how light refracts through a material. So if you're making things like water, that could potentially be interesting. But all those, you might notice, are grayed out, which is a little weird, because why is that? That is because we've got a couple of different blend modes and also surface domains. We can make like decals, we can make light functions, volume, post-processing, user interface materials, all with their own purposes. And then we have got a bunch of blend modes as well. So the most basic one and the easiest to render is just opaque, which means there's no transparency whatsoever. You're not going to be able to look through the mesh in any way, shape or form with an opaque material. But if we change this to instead being masked, you will notice that the opacity mask now becomes available. An opacity masked material will allow you to have an opaque material with holes in it. So you can't have something be halfway see-through with a masked material. There's some tricks that you can do to make it seem like that, but really all it can do is say, hey, these pixels are see-through and these pixels are not see-through. And that's why the opacity mask comes in. So again, I'm going to use this noise texture real quick for that, and I will actually disconnect the world position offset. And you can see now we can see through this at certain points in the material, which is really quite neat. If you look in the details here for the mask value, opacity clip mask value, this is the value where it decides, okay, so everything under this I'm going to be able to see through, and everything over this is going to be opaque. So if I set this to 0, you can see that it's entirely solid. If I set this to 1, it's just going to be entirely invisible. The default is set to 1/3. You can set this to like half, so everything under 50% becomes see-through, and you can do some really, really cool stuff with this. Now, next up, instead of the masked mode, we have the translucent mode, which is just a little bit more interesting because it gets rid of quite a few things here. You can't make this metallic, you can't make this reflective because you're going to be able to see through it instead. It can still be emissive, but it doesn't have a normal input either, and instead of an opacity mask, it just has a opacity. And this opacity allows you to just have any amount of see-throughness between 0 and 1. So there's a lot more freedom that you have with your opacity in this, but this also takes quite a bit more rendering power to do. Specifically, if you have a see-through material behind another see-through material, that then creates some overdraw, as it's called, and that adds up really, really, really quickly in how difficult it is to render certain pixels. So generally speaking, this is a really powerful thing to be able to do, but also something that you should probably try to avoid using whenever you can. And those are the most important blending modes. We've got a couple more, like additive, which is very similar. Additive is mostly used for things like materials, for particles and that kind of stuff. It just blends a little bit differently with what is on its background. And that gets into some like more in-depth, some more advanced, like how blending modes work to begin with. If you've ever worked with like Photoshop, you're familiar with blending modes, and you probably know what an additive blending mode does. If you haven't worked with anything like that, this is not the video to explain it in depth for you. And everything under that, we don't really want to talk about today. So those are the blending modes. Again, we've got some material domains, which we can talk about in the future maybe, and then some shading models. The most important ones being the default lit, which is just this, and then we've got unlit as well, which disables quite a lot of the pins here. So if you've got a material that only needs to emit color, it doesn't actually need to calculate any lighting information about itself. It only needs to emit colors. Or a material that just needs to be like entirely black, like you see here, that doesn't interact with light whatsoever. You set that to unlit, and that just saves a little bit of calculation power because it's not calculating stuff that you don't need it to do anyway. And then there's some more stuff that we can talk about later here, like subsurface can do some interesting stuff. Hair and cloth materials are kind of fun, but we don't really care about that for the time being, so we're going to set it back to default lit. The last thing I want to talk about for right now is having a two-sided material. If we come down into the preview settings here, we have a couple different meshes that we can preview things on. And I'm going to look at the plane for now, because as you can see, one of these sides is opaque, and the other side is entirely see-through. And that is because only the front-facing direction of any specific part of your mesh is going to render by default. Because think about it, if you have your character, it renders the entire mesh on the outside. There's no reason to render the mesh on the inside as well, right? Because you're never going to look in there, and why would you spend resources and computing power to render that? Sometimes though, you have things which you need to be able to look at from both sides. A good example of that would be like a blade of grass. Instead of modeling an entire blade of grass in 3 dimensions, you can make it flat planes and instead make those two-sided. That way they just render on both sides and you don't need to model any depth to them, and then that actually becomes more performance. There's a bunch of things that you can use this for, but don't use it as a crutch for things just not looking correct, because you're probably earlier on in your modeling process something went wrong if this is just a crutch to make things look better. Do be aware why and when you use this one. So that's just a whole bunch of information dumping on materials that you just need to get up to speed with. We need to be on the same page on what everything here means before we can move into talking about actually making the materials. So this has been a very information dense video. Moving forward, the videos are going to be hopefully a little bit less long and hopefully a little bit more actionable in their information. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,